Hi, today we are going to discuss how to evaluate limits at infinity. That means when x, what's called, is going to increase without bounds, which means it's going to head towards infinity, positive infinity, or it's going to decrease without bounds, that means heads towards negative infinity. So here is a problem to consider. You have a limit, and in this case we can consider both plus and minus infinity at the same time. Of 2x squared minus x plus 3 divided by x squared plus 5. So what are we going to do with problems like this, since it's a simple rational function? We're going to look at the highest value, the highest exponent of x, and we're going to divide every term by that. So we're going to divide 2x squared over x squared minus x over x squared plus 3 over x squared divided by x squared over x squared plus 5 divided by x squared. Right now we just expanded that. Don't worry, I know it's gotten a little bit bigger than what we expected, but that's okay. And we're going to have a limit as x approaches plus minus infinity of, so we can simplify this. That's going to be 2 minus 1 over x plus 3 over x squared divided by 1 plus 5 over x squared. So here's what we need to know. When x goes to infinity or negative infinity, expressions like this is going to go to 0. Basically anything with 1 over x to any power is going to go to 0. That means that the following terms are going to effectively go to 0. That means that this term here is going to go to 0, this term here is going to go to 0, and this term here is going to go to 0. And what are we left with? 2 over 1. So we have the limit as x approaches plus or minus infinity, 2 over 1, and that answer is 2. Yes, it is actually that simple. But this notion here, I should actually generalize it, x to the power n, and the number on top does not have to be 1, it could be any real number. Cool. Let's take a look at the next problem. So what happened there, that equation that we got, limit equals 2, from your previous math classes, you remember something about what's called horizontal asymptotes. And what we found there completed the equation y equals 2, which is actually the horizontal asymptote for that function from the previous page. So here, this function, if you graph it, you are going to see that on both sides going left and right, the function is going to approach a horizontal line y equals 2. Okay. So let's do this problem. So what is the highest exponent of x here? It's 3, right? So 2x squared over x cubed minus 5x over x cubed divided by 3x cubed over x cubed minus 3x over x cubed plus 1. So if we rewrite that with the limit and simplify that, we're going to get the limit as x approaches plus minus infinity of is going to be 2 over x minus 5 over x squared in the numerator. The denominator is going to have 3 minus 3 over x squared plus, my apology, it should be 1 over x cubed also. It's 1 over x cubed. So what are we getting here? Let's see. So now if this goes to 0, this goes to 0, this goes to 0, this goes to 0. So each one of them is going to go to 0, except just the one constant on the bottom. It's going to be the limit as x approaches plus or minus infinity of 0 divided by 3. It's going to give you 0. That is the answer here. Okay. So that would be the horizontal asymptote of this one. All right. Now, this one. Now you need to be very careful, because sometimes, even though it looks like I mean, it is a rational function, but this rational function, the terms are not quite in order. So we can still, so when we look at this, we need to find our highest exponent of x, and that's x to the fourth. It's right here, right? So we're going to divide negative 2x cubed over x to the fourth plus 8x to the fourth over x to the fourth plus 5 over x to the fourth minus 3 over x to the fourth. That's the numerator. If you want, you can rearrange them and put them in standard form. It's not required. 4x cubed over x to the fourth minus 3x over x to the fourth plus 1 over x to the fourth. So we rewrite all that. Well, simplified. X equals plus or minus infinity. So what's happening in the numerator? In the numerator, you are going to get, hold on, let me rewrite this first. With simplified form. I'm going to rearrange that. This is the one that's supposed to be first. So it's going to be 8 minus 2 over x plus 5. I'm missing x here. 5, well, it's going to be 5 over x cubed minus 3 over x to the fourth. The numerator, the denominator is going to be 4 over x minus 3 over x cubed plus 1 over x to the fourth. Zero, 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 0, 0, 0. So in this case we have 8 on top divided by 0 can do. The limit here does not exist. What that means in terms of horizontal asymptote, this particular function is not going to have a horizontal asymptote. Right. But this is all fairly trivial. You often see functions like this. So what do you do here? First of all, we need to understand the following thing. Square root, and I know we cannot take square root of each individual thing, but there is something called dominant term, and a dominant term is the first term, and that's the one that's going to take over the behavior of the function as numbers get very, very large or very, very small. So this is ultimately x to the second power here, because the square root of x to the fourth is going to give you x squared. So the way we're going to do it, we're going to consider x squared to be our highest exponent, and we're going to divide everything by that. So this is what it's going to look like. So we're going to have 6x squared over x squared minus 5x over x squared minus 3 over x squared. Okay, when you divide when you want to take this radical expression and divide that by x squared, when x squared goes underneath the square root, it's going to become x to the fourth. The proper way to rewrite that will be 4x to the fourth over x to the fourth. That's x squared squared plus 5x squared over x to the fourth plus 1 over x to the fourth. Don't worry about that square root and all these other things. It looks a little intimidating, but that's not going to stop us from finishing this. X approaches plus or minus infinity. Okay, so let's rewrite this first. So it's going to be 6 minus 5 over x minus 3 over x squared divided by the square root. So that's 4 plus 5 over x squared plus 1 over x to the fourth. So with all the properties of limits that you familiar with, all these can be treated individually. This is 0, this is 0, this is 0, and this is 0. So the only terms that you are going to have left now are the 6 and the square root of 4. So we're going to get the limit as x approaches plus or minus infinity of 6 over square root of 4, which is going to be 6 divided by 2, and that's 3. Okay. You probably remember I mentioned in the beginning, because we do actually have two separate situations. You can go to positive infinity or you can go to negative infinity. So far with those 4 problems that we did, it didn't actually matter. And you may start thinking, well, it's probably not going to matter all the time. No, that's not actually true. There are functions where it does make a difference whether you go to positive infinity or you go to negative infinity. And the limits may turn out to be different. In this case, it's the same. Alright, so let me show you that. So you have this, it looks a little scary again, but we don't need to worry about that. So we got this expression, and we're going to have to consider 2 separate cases. In this case, it will give you different values. So the function is exactly the same. We don't have to worry too much about what it is. So we x to the 6th, the square root of that is x cubed. We do have the same exponent, so we divide everything by x cubed. So it's going to give us 3x cubed over x cubed plus 4x squared over x cubed minus 1 over x cubed. I know there's a lot of terms on the bottom, but don't worry. Square root of 9x to the 6th. So we're dividing by x cubed. X cubed needs to go under the square root. It's going to become x to the 6th. Remember, square root of x to the 6th is x cubed. Plus 4x to the 4th over x to the 6th minus 3x cubed over x to the 6th plus 11 over x to the 6th. You can have a lot of terms here, but really the only terms that matter here are the terms with the highest degree of x. Okay, so if I rewrite that, it is going to be 3 plus 4 over x minus 1 over x cubed divided by the square root of 9 plus 4, there's no x here, over x squared. Alright, fix this. Minus 3 over x cubed plus 11 over x to the 6th. Okay? And you should see, because we go to infinity, this is 0, this is 0, this is 0, this is 0, this is 0. And the only thing that's not 0 is 3 on top and the square root of 9 on the bottom. So it is going to be 3 divided by square root of 9, which is actually 1. Right? So for the other one, we are going to divide by x cubed, right? But what's going to happen is, because the in that case, as x is going to go to all the other work's going to look the same, but as x goes to negative infinity, here's what you need to understand: the square root on the bottom is always going to stay positive, right? Because even no matter what kind of number, as long as it's not a negative number under the square root, the whole thing is going to turn out to be positive. But the numerator there is going to turn out to be negative in the long run. No matter what's going to happen with the other two terms, x cubed is going to control, if you remember behaviors of polynomial functions, since this has a positive leading coefficient and negative odd degree on the left hand side where the negative infinity is, that function is going to have, that function is going to go down. So what's happening here is that the numerator is actually going to approach negative 3. So it is negative 3 divided by 3, which is going to give you negative 1. So this limit here is going to equal negative 1 as x goes to negative infinity, but as x goes to positive infinity, the limit's going to go to 1. You can actually graph this function using any kind of a tool or Desmos, GeoGebra, or even your graphing calculator, and you will see that when the graph goes to the right, it's going to approach positive infinity. When the graph goes to the left, it's going to approach negative infinity. Okay, so I hope this helps. We'll see you next time.